H100 versus RTX 6000 Pro, the LLM Showdown. NVIDIA's H100 and RTX 6000 Pro GPUs have become the hardware titans of large language model LLM serving, but their real-world performance, cost efficiency, and reliability for next-gen inference workloads are much debated. Rigorous benchmarking with VLLM and OpenAI's GPT-OS 120B reveals that the H100 96GB delivers 1.71x higher total token throughput and nearly twice the speed generating the first token, lower time to first token, or TTFT, compared to the RTX 6000 Pro. The H100's advantage stems not just from core compute. It boasts high bandwidth memory HBM, which can move data 2x faster than the DDR-based RTX 6000 Pro, a consistent bottleneck for huge model weights and rapid token streaming. However, the devil is in the details. Performance varies depending on quantization support. Hopper, H100's architecture, enjoys mature FP4 kernel-level optimizations, but Blackwell RTX 6000 Pro users often rely on software fallbacks like the Marlin kernel that can throttle compute-heavy workloads. Configuration alignment, driver versions, CUDA, VLLM releases also plays a heavy role. Minor mismatches can tank throughput by up to 50%. User-reported alternative benchmarks even show the RTX 6000 Pro 96GB outpacing H100 SXM5 80GB for batch serving in some setups, but H100 retains the edge in interactive use due to consistently lower per-token latency. Price performance is where the RTX 6000 Pro claws back relevance. With an H100 costing 2.5x more than a Pro 6000, many buyers may find value stacking multiple Pros, especially as kernel support matures. Yet, installation remains a minefield, and time to first token is, frankly, horrible, 20 to 75 seconds, far from consumer-grade experiences like Grok, 500 to once. For LLM serving at scale, the H100 remains king for now, but smart buyers should watch Blackwell's evolving support closely. VRAM mods, 490s, and the new local AI economy. The DIY spirit is alive and well in GPU land, evidenced by hands-on hardware mods to boost LLM capacity and cost-effectiveness. Enthusiasts are retrofitting RTX 4090s, upgrading them from stock 24GB VRAM to 48GB in a bid to run bigger models locally, often outpacing the Pro-class previous-gen A6000 cards at a similar or lower price. A modded 4090 48GB shows only a 1 to 2% latency bump on small models, making it potent for single-card deployment and multi-GPU servers if you can handle the noise, vacuum cleaner territory. Price sensitivity drives this trend. As new board pricing spikes and unavailable next-gen 5090s, modded 4090s hit a sweet spot for buyers needing real VRAM at a reasonable outlay. The main caveats: high fan noise, P2P, peer-to-peer, driver limitations, and the need for advanced thermal management. Water blocks and custom airflow solutions are the next logical step for homegrown AI clusters. While such mods won't touch H100 level performance, they enable practical, large context inference for local power users, especially with clever power capping and memory swaps. Flash attention install tricks for speedy inference. Many AI practitioners underestimate the complexity of installing and optimizing Flash attention, a critical package for LLM inference acceleration, across custom environments. Lessons from distributed testing show that pre-built Python wheels are the path of least resistance. Matching CUDA and PyTorch versions tightly is essential, as even a minor mismatch prevents installation or sabotages performance. Building from source offers ultimate control and compatibility with the freshest GPUs, but requires an up-to-date CUDA toolkit, C++17 compiler, and exact GPU architecture targeting, e.g. Flash ATN CUDA Arch X90 for H100. Using tools like UV or Ninja allows parallelized builds, with flags for skipping or forcing specific build behaviors. In environments with strict security policies or unusual hardware, source builds may be unavoidable. For everyone else, pre-built wheels remain the pragmatic choice. The community's experience is clear. Flash A10, when correctly installed, provides order-of-magnitude speedups for batch and streaming inference. But getting there involves detailed dependency matching, a typical hazard in the still-maturing ecosystem of AI tooling. Section llama.cpp, Qwen3 Next, and the open model pipe llama.cpp continues to drive local AI experimentation, with rapid community-driven efforts to support emerging open models like Qwen3 Next. While pull requests to integrate Qwen3 Next are progressing, user sentiment is mixed. For some, Qwen3 Next models fail to reach the utility of Qwen 2.5 or dense architectures, sometimes struggling with basic code or prompt-following tasks. Still, the momentum for open, performant local models is real. Every time support lands for a new architecture or tokenizer in llama.cpp, the community responds with rapid-fire testing, bug fixing, and deployment advice. The frustration often lies in inconsistent installation experiences. Even with burgeoning, performance-optimized packaging attempts for llama.cpp, the number of flags and hardware OS quirks exaggerates the challenge for less technical users. Despite these hurdles, open-source LLM serving keeps inching toward usability, especially as critical tools like flash attention and performance-optimized builds become easier to install and maintain. NVIDIA's Nemotron Nano 12B V2, a reasoning powerhouse for LLM agents. NVIDIA's Nemotron Nano 12B V2 demonstrates a new generation of LLMs designed for both explicit reasoning, show your work, and direct, concise answers, according to user system prompt instructions. Its hybrid Mamba 2 transformer backbone is optimized for high throughput and extremely large contexts, up to 128K tokens, while keeping computational cost low with only 4 attention layers. Dual mode operation lets users toggle reasoning on-off, with support for budgeted, token-capped explanations that fit real-world needs, e.g. low-latency apps or edge devices. Benchmarks back the design. Nemotron Nano 12B V2 posts near 98% accuracy on hard math tasks, Math 500, with trace-first, stepwise reasoning mode consistently outperforming direct answer mode, especially under complex question sets. The architecture is tightly coupled to NVIDIA's hardware ecosystem, providing optimal performance on A10G, H100, and A100 GPUs, making it a compelling drop-in for enterprise search, RAG, or multi-agent deployments. Tool calling is natively supported via OpenAI's standard API format, making logical reasoning and action orchestration explicit and auditable. For deployment, NVIDIA offers detailed guidance for VLLM, TRT-LLM, and transformers integration. Budget control on thinking tokens is not just a party trick. It's a practical lever for mass-market chatbots and automated agents that need to manage cost and speed in production. Nemotron's strongest play is readiness, a rare blend of high accuracy, detailed reasoning, and turnkey support for commercial use. Evaluating the next wave of agentic AI with Gaia 2. The nature of AI agents is shifting, and recent community efforts led by Hugging Face, Gaia 2, and ARE are pushing the boundaries of what it means to evaluate agentic LLMs. Traditional agent testing is broken. Most benchmarks stress only simple tool use in deterministic environments. Gaia 2, by contrast, throws agents into noisy, unpredictable scenarios, ambiguous instructions, conflicting sources, time-sensitive actions, failing APIs, mimicking the messiness of real human tasks. The paired ARE framework lets researchers and practitioners simulate realistic app environments, email, calendar, messaging, inject asynchronous events, and log every tool invocation and thought process. All traces are publicly exportable for reproducibility and debugging. Notably, it natively supports MCP, Model Context Protocol, so agents can experiment with context augmentation and external tool calling. Results from the launch leaderboard are a reality check. GPT-5 currently leads, while open models like Kimi K2 are strongest among open weights. Even at the high end, agents stumble over ambiguity, adaptation, and especially cost-time efficiency. Many can solve the tasks only by burning thousands of tokens or running for prohibitively long times. Gaia 2 and RE mark a new standard: rich, open, reproducible agentic evaluation that moves beyond toy tasks, emphasizing efficiency and robustness in the face of real-world adversity. Model, agent, and AI tool ecosystem: the rise of modularity and self-hosting. Open infrastructures for LLM and agent deployment are blossoming, with solutions like Agentic, Kubernetes native agents, lowering the barrier to robust, scalable, self-hosted AI. Agentic uses simple YAML to manage agents over OpenAI, Anthropic, Google, Gemini, or self-hosted VLLM endpoints, with GitOps, multi-provider switching, and health monitoring built in. For local inference, projects like MyLocalAI focus on privacy, extending beyond basic chat to planned file analysis and web tools in a self-hosted UI. Directory-aware tooling such as Twiggy augments AI coding assistants, like those in Cursor AI, providing real-time, comprehensive code-based structure, giving bots full project awareness for smarter refactoring or search. Zen streamlines batch usage of code LLMs, e.g. Claude Code CLI, introducing calm error tracking, scheduling to avoid token exhaustion, and unified budgets for parallel instances. Modularity is key. Extensible AI video generation pipelines let users swap in LLMs, TTS, image video models, and soon even music generation in Pythonic plug-and-play fashion. The open model and API ecosystem is steadily enabling more sophisticated task automation, orchestration, and agentic chaining without cloud vendor lock-in. Software engineering and training data, a crackdown on LLM compliance and benchmark contamination. The software engineering world is looking for ways to ensure responsible LLM adoption, especially as AI coders become fixtures of daily development. The SubUI Bench Pro benchmark sets a new challenge for LLMs and AI agents. Perform actual, long-horizon code-based fixes, not just toy PRs, evaluated under reproducible Docker environments at scale. It's a proving ground for code agents with real-world complexities, interdependencies, multi-step refactoring, and environment-specific quirks. Meanwhile, recent research exposes a compliance gap. Most current training data detection (TDD) methods, techniques designed to discover if proprietary code leaked into an LLM's training data, work well only for verbatim matches, but struggle with semantic Type 2.4 code clones. This is a core risk. LLMs can memorize or replicate patterns, not just exact snippets, confounding both copyright enforcement and benchmark purity. Detectors based on perplexity, min-k-cent, and other scores degrade as code mutates, and even the best require calibration. The research community is called to develop code-aware detectors that can recognize membership beyond shallow text matching, ideally open-sourcing more robust, context-sensitive benchmarks. Algorithmic pricing laws and AI regulation. New York sparks a U.S. trend. Algorithmic pricing, where retailers dynamically set prices based on personal data, faces a major regulatory shakeup. New York's new Algorithmic Pricing Disclosure Act, the first of its kind in the U.S., forces retailers to label any price set by an algorithm using your personal data directly next to the price. Fines are $1,000 per violation, and the law's scope is intentionally broad, covering any use of personal data well beyond simple time-of-day pricing. While enforcement is currently stayed pending an industry lawsuit, the implications ripple nationwide. Other states, including Texas, Vermont, California, Minnesota, and Ohio, are weighing similar or even stricter measures, from outright bans to broad disclosure requirements. Retailers must now audit the data flowing through their algorithms, set up proactive labeling and documentation systems, and monitor new state-by-state obligations. The message is clear. As AI-driven personalization scales, transparency is becoming a legal baseline, not just an ethical bonus. Browser, OS, and tooling, Factorio, KDE Linux, and Immutable OSes. Outside the LLM sphere, user-centric infrastructure is surging ahead in security and reliability. Factorio, the long-loved automation game, now code signs its Windows executables, finally silencing Windows Defender's false positives and giving users end-to-end trust. But the update does much more. Enhanced mod APIs, circuit network splitters, heat source upgrades, and bug fixes abound, reaffirming the value of meticulous, long-term product maintenance in the software world. In the Linux ecosystem, KDE Linux's alpha release marks a fast-evolving trend. The Immutable desktop, with pre-built, Flatpak managed system images, atomic updates, instant rollbacks, and a reference KDE Plasma experience. Reviewers praise its astonishing stability and performance, even on old hardware, while raising the inevitable immutable trade-offs. Custom driver installs, deep UDEV tweaks, and non-standard device support can be tricky or impractical. For most users, the usability and polish of modern KDE Linux, combined with fast, atomic upgrades and a cleaner application stack, hints at a promising future where the typical Linux desktop rot, package conflicts, update regressions become things of the past. But as always, advanced users and tinkerers will have to balance flexibility against system integrity. Next-gen generative diffusion models and web design models. AI creativity tools are maturing, marked by improved alignment with human preferences and sharply focused model design. Tencent's SRPO paper introduces Direct Align, a method to optimize diffusion models for image synthesis directly along the entire generation trajectory with text-conditioned reward signals, instead of relying on iterative multi-step denoising. By interpolating noise priors, SRPO cuts compute cost and reduces the need for continuous reward model retraining, boosting both realism and aesthetic quality, tripling their Flux.1 dev model scores in human testing. This approach enables practical, real-time reward customization in diffusion pipelines, online, text-based prompt feedback, a leap for content creators and fine-tuning practitioners. On the web design front, models like Teslate's WebGen 4b preview specialize in a single domain, production-grade semantic HTML CSS Tailwind websites, packing 4b parameters into a locally run model that outputs visually strict, mobile-first snapshots from simple prompts. Community examples show clean, responsive designs with minimal fuss, filling a long-standing gap in generative UX tooling. These advances show the field's maturity. Models purpose-built for clear contexts, equipped with modular, user-in-the-loop customization, not generic one-size-fits-all generators. Real-world RAG enterprise lessons. Enterprises deploying retrieval-augmented generation RAG systems continue to learn the hard way. Naive, just-chunk-it approaches to document parsing can kneecap accuracy, with handcrafted chunking scripts yielding up to 20% better retrieval and response quality. Without robust tooling and early investment in data preparation, even the shiniest LLMs become little more than error machines glued to incomplete or context-mangled data. Meanwhile, the arms race of uncensored LLM variants continues in the background, serving demand for models that bypass safety filters and corporate guardrails. Security and ethical debates aside, the open-source surge persists, inspiring both genuine accessibility and ongoing headaches for downstream developers and enterprise compliance. Taken together, the AI ecosystem, from hardware and model design to regulation, software engineering, agentic evaluation, and UI, continues to mature, but not without new challenges. If the past month is any predictor, the drive for greater transparency, reproducibility, and hardware-software synergy is only accelerating.